Bridges by Reyansh Kansal. Table of contents. What types of bridges are there? Page 2. Truss bridge. Page 3. How much a truss bridge can usually hold. Page 4. Comparison. Truss bridge versus beam. Page 5. Materials. Page 6. Procedures. Page 7. Research. Page 8. Data table. Page 9. Analysis of data. Page 10. What my bridge is good for. Page 11. Why my bridge is good. Page 12. My bridge weight test video. Page 13. Bibliography. What types of bridges are there? There are many types of bridges. Here are some examples. Truss bridge, cantilever bridges, beam bridges, tiered arch bridges, suspension bridges, cable stayed bridges, and pedestrian bridges. Truss bridge. What is the meaning of a truss bridge? Truss bridge is a type of bridge whose main element is a truss, which is a structure of connected elements that form triangular units. Truss is used because it is a very rigid structure, and it transfers the load from a single point to a much wider area. Truss bridges appeared very early in the history of modern bridges and are economic to construct because they use materials efficiently. How much can a truss bridge usually hold? A truss bridge is capable of holding a huge amount of weight. For example, the global truss bridge can hold 20,000 lbs, or pounds. That proves truss bridges can hold a lot of weight. Truss bridges also can hold 40 pounds per square foot. Comparison: truss bridges versus beam bridges. Truss bridges are more likely to be more supportive than beam because truss bridges are 10.0736 times stronger than the span or beam bridge. Materials. I used 200 popsicle sticks. I also used Gorilla Wood glue, strong string, sand, and a bucket. Procedures. Step 1. I use 15 popsicle sticks for base A. Step 2. Repeat step 1 but make it for base B. Step 3. On base A, I use 10 popsicle sticks for 5 triangles. On Step 4. On base B, I also use 10 popsicle sticks for 5 triangles. Step 5. Then, I used 8 popsicle sticks on base A for combining the 5 triangles. Step 6. Repeat step 5 but for base B. Step 7. I used 36 popsicle sticks and divided each into groups of 9 to make 4 thick stacks of 9 popsicle sticks. Step 8. I glued 4 thick stacks of 9 popsicle sticks to bridge a gap between base A and base B. Step 9. Lastly, I used 60 popsicle sticks and separated it into 4 stacks of 15 popsicle sticks each and glued it on top of the bridge gap so people and vehicles could go on it. Research. Step 1. Research about bridges. Step 2. Choosing a bridge. Step 3. Making a bridge. I made my bridge a truss bridge out of 200 popsicle sticks. Step 4. Testing. I did 5 trials. First, I put rocks. Second, I put another set of rocks. Third, I put fertilizer. Fourth, I put another set of fertilizer. 5. I put a 10-pound dumbbell. Data table. Trial. Weight 1. What I put was fertilizer, and how much I put it was 10 pounds. So, weight 2. I put another set of fertilizer, but 15 pounds, so that equals 25 pounds. Weight 3. Rocks. I put 14 pounds rocks, so that equals 39 pounds. Step 4. Another set of rocks, but 18.2 pounds this time, so that equals 57.2 pounds. Weight 5. I put a 10-pound dumbbell, so that equals, in total, 67.2 pounds. Analysis of data. As we all know, fertilizer is really small and can be evenly spread out, so it did. But when I put a rock, the bucket tilted. So what I did was, since I needed to balance it out, I put a 10-pound dumbbell to balance it, but It wasn't enough. Still, the dumbbell had 5 pounds on each side, but the rock leaned more because the side on the rock had more mass and weight because the dumbbell just added more. So I added a rock to the side that was facing more up to balance it out. What my bridge is good for. Cantilever bridges are meant for span long distances. Cantilever bridges are well suited for spanning long distances, making them ideal for crossing wide rivers, deep gorges, or other challenging terrains without the need for extensive support structures in the middle of the span. Pedestrian bridges are meant for and are built over roads that require people to take longer, often inaccessible routes up and over many lanes of car traffic without impeding the speed or movement of vehicular traffic. Truss bridges are meant for and are supported by at the ends by abutments and sometimes in the middle by piers. A properly designed and built truss will distribute stress within its structure, allowing the bridge to safely support its own weight, the weight of vehicles crossing it, and the wind loads. Why my bridge is good. Even though cantilever bridges may be good for situations like these, cause it's bridge structures with piers that have high placidity or high ductility due to the large expansion of girders and the increase of deformation of piers due to the effects of concrete creep, drying shrinkage, press stress, and temperature change. Truss bridges are also useful, while truss bridges are great for short spans, what makes them versatile is their ability to go long distances and still support large loads. With the polygonal design of the truss, it's possible to cover long distances. In particular, truss bridges can be needed in areas with extreme weather. Video time. If you guys want to watch this video, you can go ahead. Bibliography. I used a book about everyday engineering bridges on Sora. 3 websites are, you can click any of these websites and it will lead you directly to where I found them. A YouTube video, feel free to click on that and watch where I got this information from. Thank you.